Welcome everyone who are joining this technical session. I am Dinesh Manogar from UCAL Aerospace and a member of Organized Committee for Aerocon 2020. It is my honor and privilege to chair this section on disruptive technology in aerospace and aviation. To begin with, I welcome the keynote speaker for this session, Mr. Ambir Dubey, the Joint Secretary at Ministry of Civil Aviation, Government of India. He is an alumnus of IIT Bombay, IIM Ahmedabad, and has the professional experience of over 27 years. He was one of the 9 professionals selected in September 2019 by Government of India to join as Joint Secretary in a union government. At the Ministry of Civil Aviation, Amber is looking after IT, digital innovation, skill development, and job growth, etc. Amber has helped in drafting the Vision 2040, National Civil Aviation Policy, and the policy framework for Regional Connectivity Scheme. Amber was honored for his valuable contribution to Indian aviation in 2012 by Aviation Minister. Welcome, Mr. Ambir Dubey.
Thank you so much. Very kind of you. You want me to start speaking now or? Yeah, okay. Thanks so much, everyone. It's a big honor to be speaking to such an august audience. What I'll do is I'll keep it very short, and I would rather take questions than going on a long speech. It's late evening for everyone, and I can just very easily bore you to death. So, just a quick summary. We don't even need to say how important drones are, and for the government, for Ministry of Civil Aviation, DGCA, Airports Authority, and all the associated ecosystem for drones. This is a very, very critical sector for us. Drones are the future. In fact, even regular aircrafts and passenger aircrafts will become drones maybe in 10 years' time, maybe 12 years' time, maybe even 5 years' time. We don't know. The pace at which technology changes, it can really, really surprise all of us. So even a simple Indigo and SpiceJet aircraft may become a drone with the pilot actually sitting on the ground or maybe even underground. So that's the future. At this moment, things are a little, what do you say, we are evolving. So a lot of our regulations, our draft regulations, after a lot of public feedback and incorporating feedback comments, we send it to the Law Ministry. The Law Ministry itself has sent it back to us with their own comments. And we are in the process of incorporating that. And then we will send it back to the Law Ministry. And once it's approved, we'll release it and gazette it. So the rules are in place. What we're doing is during that process, we're also focusing on what you call the 3 basic things of an industry, which is DSR, demand, supply, and regulations. So we're also focusing on the demand side, that while the regulations and the CAR and all those things are being streamlined, the show must go on. So on the demand side, we're encouraging all private sector and government, especially government sector, because as a ministry for us, it's easier to interact with other leading PSUs and the end users, whether it's healthcare, agriculture, mining, and all kinds of transportation industry, highways, ports, airports, power sector, telecom sector. We're encouraging all of them. We're having separate conversations with each one of them, railways, and telling them to use drones as much as possible, because it can give you fantastic HD quality pictures sitting in our office with no human intervention, very little human intervention. And you get absolute, it's like watching a live telecast of the IPL from Abu Dhabi sitting here at home. And all the end users who have used it are seeing the huge value of it. We also saw the locust and the corona calamity, even though both were calamities, they came as a big opportunity. Every calamity actually gives us an opportunity. So on corona, we saw the value of drones all across the country. Kudos to all those youngsters who helped out all the law enforcement agencies and healthcare agencies to maintain discipline and social distancing, and also nail people who are habitual offenders and getting together and violating the rules. Similarly, on locust also, we could move, various ministries could work together and DGCA, and immediately in less than 9 days after getting the orders from the Cabinet Secretariat, we could actually issue work orders without a tender to 5 drone companies spread out all over the country in May end and June beginning, actually, when it was the whole country was under shutdown. complete lockdown, and we could actually manage to move those from all over the country into 5 allocated districts in Rajasthan, and they did fantastic work in that heat where there was no hotels or restaurants. The transportation was a challenge, and going into the interiors of the villages off the highways and doing fantastic work. I mean, that really gave a big push up to the drone sector, and also showed the capability and the commitment of these youngsters who moved from different parts of the country, from Bhubaneswar, from Nagpur, Mumbai, from Cochin, from Bangalore. Drone pilots were somewhere, drones were somewhere, the technicians were somewhere else, and to mobilize all of them and talk to the police authorities and get their curfew passes. It was a massive activity, but it was all done, and again proved that once Indians decide to do something, they can really surprise everyone. Then there's this Swamitwa, you might have seen, 6.6 lakh villages, 662,000 villages have to be mapped, and the Prime Minister has given a very stiff target of December 2024 to finish it off. The first 1 lakh property owners have already been given digital property papers through this Swamitwa scheme, as we call it. And there also we worked with the Ministry of Panchayati Raj, DGCA, Survey of India, and things moved. So I mean, I can just go on and on. The idea is not to bore you on an evening with such facts and figures, but these facts and figures are all on the official on our website, and all our orders are listed on the website. And people can actually refer to that and see verifiable information as to the speed at which we are moving. I'll just touch upon very quickly on the drone schools, because we now want to bring all formal drone training. So in a space of last 2 or 3 months, we've managed to clear about 15 drone schools. And surprise, Hyderabad has 4 out of those 15. So kudos to Biryani country. But so 15 drone schools have already been approved. These are FTOs. Then we've also come up with the latest circular, which opens up to hundreds of drone schools across the country. We have made increase the eligibility from flying training organizations, basically flying schools, to incorporate all central government agencies, all state government agencies, all universities, recognized universities, and all drone manufacturers. All of them are now eligible to provide drone training. They can just approach DGCA, fill up the forms, and we'll try and expedite. And if there's any delay, please do let us know. On the Beyond Visual Line of Sight, which is the next frontier for drones, 20 consortia, as all of us know, 20 consortia have already been approved. Their security clearances are currently on, and one by one, because each of the consortia also has 4 or 5 members, and many of those members are actually corporates, and then within the corporates they also have 3, 4, or 5 directors. So that's why the Home Ministry is struggling to speed up the clearances. But we have got a fast track approval. We had our own discussions with MHA, and they have just based on an email. So most of these BVLOS consortia are sending us their papers. I mean, the Form 2 and 2A. By email, and through email we are sending it. Otherwise, there's a long process for security clearances. And just by email, without any Aadhaar or passport or whatever, just the basic information that we want in Annexure 2 and 2A of the CAR, we are sending it to Home Ministry, and they are fast tracking all the approvals only for BVLOS. So that is happening. At the moment the security clearances are done, people can actually fly, and then we can come up, look at the test results, look at the failure. We want more and more, a lot of failures to happen, because just like drug trials, the more failures that happen, they make us smarter. Every time there's a communication link breakdown, or a return to home, or a drone just disconnects, or a drone just falls off the skies, it actually helps us then do a diagnostic and a post-mortem and resolve those issues, so that in real life it doesn't happen. On the Digital Sky platform, it's a single one-stop shop platform, which will be very powerful platform. A lot of work is happening. We have a temporary setback at the moment because the maps. Because see, when we give you a flight path clearance, flight path clearance, I mean, it's a 10-second job. You can just go on the internet and get a boarding pass. So issuing the boarding pass is not the key issue. The key thing is your origin and destination have to be mapped against the red zones and the yellow zones. And that zonal map is currently under discussion at both MOD and MHA and the security agencies. And there is some disconnect, and we are trying to resolve those issues. And because they've never done this in the past, like last 70 years, they've never actually put out a map approved by a security agency of this high resolution in the public domain. So there are natural security concerns, because many of those Many agencies are very uncomfortable at putting some of the red zone details in the public domain. So should we keep it in the front end, back end? So there's a lot of debate happening behind the scenes, but we are very hopeful that within a month or 2 months, by December, we have put a hard target. We will resolve these issues, and at least the flight clearances and permissions will start happening. And mid of next year, we'll also have real-time flight tracking, because that's very critical also from a security perspective, and also from a deconflicting static and dynamic deconfliction between two drones who could be flying in the same area, same airspace, or even a drone and a manned aircraft could be flying in the same zone. Okay, and to deconflict them, we need real-time information. Even a drone which may veer off because of weather reasons or hacking or some communication link breakdown, and it goes into a red zone, immediately it has to be brought back. So for all these things, we need real-time tracking, and that is once the phase 1 is done. In phase 2, in around mid of next year, we hope to get the real-time tracking also on. And the various other things, like we've also tried to outsource the whole certification process, because we didn't want to waste your time coming to DGCA and MOCA and go through the process, because see, we are policymakers, DGCA is regulators. So for certification, we actually outsource it to QCI. It took 8 months of hard work during the Corona times, and we managed to come out with the manual. There were 3 different committees getting each one's approved. Many of these are external people and technical people from academia and from the industry, retired DRDO and CEMILAC people, and so on and so forth. And so now it's all done. The QCI manual is ready. QCI has been given the mandate, and QCI itself then went ahead and has appointed TQ Cert, Tata Quality Cert, for a third-party certification. So now our job is over, and we have the third party who can do it in a much more faster way, and releasing DGC and MOCA resources to do other things which we are supposed to do. The UTM policy is very critical as to how will we manage between the manned and the unmanned, and between the unmanned space. So that policy is currently the first draft, the discussion draft is ready. It's just been put up to the Secretary Civil Aviation for his approval, and once it's approved, we'll put it in the public domain for your feedback. And once that is brought in, we'll then release the discussion draft, and based on the comments which you receive, we will finalize them, and based on the discussion draft, we'll come up with the draft UTM policy. So that will open up a new era of growth, wherein we will try and bring that sort of coordination between the manned and the unmanned the aircraft space. So what I'll do is I'll stop here, because I think this is a very short time to discuss such a such a complex issue. Let's make it a little more interactive. So Ravi or Prabhakar, anybody who would like to ask questions, it's much more interesting then.
Excellent. Good evening. Are you able to hear me? Excellent.
Yes.
First of all, thanks, Amber. It was a wonderful insight that you have given. In fact, the way government is working, it's electrifying and heartening to know the speed that you people are making it happen. In fact, it is visible in this.
Everybody loves the slide. I love every word of it, but this is the time to hammer. Please go ahead.
Okay, great, excellent. Nice to hear that. So there are many questions from the chat bot. In fact, we may not be able to take that many questions because of paucity of time. But I will give you one question. This question is coming from Vivek. Okay. The question is, are there any suggestions and guidelines for people who wants to take up career in drone pilots and drone operations? Any thoughts from your side?
I'm sorry, the question. Ravi, can you repeat the question, please?
Yeah, the question is, are you able to hear me? Yes.
Yes, I can.
Yeah, the question is, the people who want to take the career as drone pilots and drone operators. So what do you suggest for them? There are many young professionals who want to take up careers for the drone.
Well, absolutely, it's a great opportunity, and these cases is just I won't go much into details, I'm short, but just to talk 6 points exactly, this is thousands and thousands, just one program of the government there, which give digital property rights, which limestone, those places. Just map it out, and then convert those things, tie together, and then they create digital copyright systems, which a villager can actually download from on his mobile phone. So as I said, the program. This is just one program. Opens up thousands of jobs for worldwide. So I don't know where to start and where to end. It's too many opportunities. Anybody looking at that stuff, please come in. And so, as I said, that just clearly 15 rules in the last months, and we've also seen the open it up all central government, state government entities, universities, manufacturers. Everybody is now eligible to provide training because they apply to the 9 years, but we expedite that because we want more and more people to take formal training. And also because there is a security and privacy issue involved also. And at the right time, once there's enough news and enough content to say that 6 months down the line, we may actually mandate it. So right now, we are keeping it a little flexible, but maybe 6 months down the line, we have to mandate that if you want to work with any government entity, you need to have a formal pilot certificate from the authorized rules. Ravi.
There is some audio problem. So there are, I think it should be clear now. So the next question that has come from the startup side, okay? So they're telling the startups in aerospace and defense take high risk as gestation period of investment is pretty long. So in that particular scenario, what is your suggestions, and also are there any specific initiatives Government of India is driving to encourage startups in this space?
Without question, so I'll say that jump in, you have to be a little foolish, a little mad, a little crazy, in India, and we appreciate that. And I say that with respect, because I deal with a lot of youngsters, the academic young.
Amber, one small suggestion, there is a lot of echo coming from my side or your side. Can you just check once?
Okay, now. What do I do? I'm using the same setup that I use for my CCs. What I can do is maybe, okay, somebody said that just refresh our browser. So I just.
So we will be back. Looks like there is some audio problem from the other side. Just hold on for a minute. We have a pretty interesting.
Am I still echoing or?
Perfect. It is wonderful. Thank you. Sorry for trouble.
No problem. These are technology issues. So anyway, Ravi, so I got the question. I think this was my request to all our budding youngsters and entrepreneurs would be just jump in. And yes, you'll have to be a bit ready for the long haul because entrepreneurship is not easy, especially in India. I mean, even Steve Jobs and the Zuckerbergs and all that. All of them struggled, even the US, which is like the El Dorado and the Promised Land and the American Dream, etc. Both of them almost wanted to sell off their products, sell off their companies at some throwaway price. And somebody told them, come to Neem Karoli Baba in India. And they came back and got some, God knows what Diksha they got in Himachal. And then they went back and they became the Steve Jobs and the Zuckerbergs, which are now legends. So I think entrepreneurship is tough. And but the situation is improving in the current government. You've seen the Honorable Prime Minister himself is so pro young entrepreneurs, the Young India Mission and Startup India, the science and technology missions. All of them, we are all under tremendous pressure to help out all our youngsters. Whatever help you require, we'll be very, very happy to reach out to you. We also have WhatsApp groups. We have the Drone Federation of India, FICCI. All these agencies are very active, and they do help out all the youngsters. And in fact, most of the successful people who are working with the armed forces on the drone side and also on the civilian side, they're all youngsters. They're all college guys who just came out of college maybe 2, 5, or 10 years back, and they're doing tremendous work. And yes, things were slow, but we are trying to speed up as much as we can. So don't worry, just jump in. And I mean, what have you got to lose? Maybe you lose 2 years, 3 years, and if it doesn't work out, you can always, I mean, you guys are so sharp, you can always take up a regular job, and then maybe 5 years down the line again, take another plunge. So no risk. This is the time. Jump in. Ravi? You're muted. Ravi, you're muted.
Yes. One more last question, Amber. Thank you for that. One more last question because we are running out of time. But all the other questions we'll post.
Ravi, after this also, you can always, I mean, send us a question. You have my email ID. If there are some 5 or 10 unanswered questions, I'll be very happy to answer them because I know time is short. Please go ahead.
Excellent. The question is coming from the OEM side of it. What they're asking is, majority of the drone parts today are imported. Are there any support systems in place for drone manufacturers, drone operators in India? Can you provide some insights on that?
Good question. And if you want an honest and a blunt answer, because there's no point going goal, jalebi answers. See, the unfortunate answer is yes, they are being imported, and we are concerned about that. And they're all mostly coming from our country, north of us. I won't name the country, but we have our own very strong feelings against that country. And that has to be converted, I mean, has to be turned around. And yes, that country did have a head start, 10 to 12 years head start, but we have to catch up. I mean, even they caught up. I mean, they didn't invent the drones, but they beat the whole world. And now it's our turn to, despite all the challenges and problems, come in and I mean, keep trying. And Indians, as I said, we did the same thing in the early 80s when some very sharp people from Mumbai and Bangalore and Hyderabad got together and created this IT revolution in the 80s. They didn't invent the computers, they didn't invent the languages, but using the computer and the languages, I mean, they created magic, right? And the rest is history. And as the Honorable PM says, this is our IT moment. 40 years later, 2020, this is our IT moment where we didn't discover or invent the drones, but and also maybe the language, but using the drone and the language, we can create packages, we can create the analytics, we can create specific apps and specific use cases in agriculture, healthcare, in transportation. I mean, God knows it's an unlimited kind of opportunity space which Indians can use their skills in computing and frugal manufacturing and IT and create products which have relevance across the world. So this is our moment. Now, coming back to the components part, see, components works on volume. There's hardly any margin. So the only way you can beat this one particular country up north is through volumes. And that again comes back from what I said earlier, DSR, demand, supply and regulation. So as government, what we can do is to work on demand and keep pushing other ministries and PSUs and even the private sector doesn't need any push. But on the government side, to use more and more drones, the more and more RFPs come out, the more and more volumes grow. Then for these BMP, as we call it, battery motors, propellers, FCM, the ground control station, etc. I mean, and the airframe, they will be big enough market that it will encourage people to get into this. So yes, we need to get the critical mass, and even in China also, it was not done overnight. So they had a head start, and now we are catching up. And I'm sure maybe in 2 years, 3 years, or 4 years of time, we'll have enough volumes in the country by working on demand, supply, and the regulations to create a critical mass for component manufacturing. And once component manufacturing happens here, again, we will catch up. Now, the key part is, which I'd like to highlight, is that the cost of the material is only 10%, just like your laptop or the PC through which I'm speaking right now. The cost of the hardware is only 10 to 15% of the total asset. So in the drone also, if I sell a 2 lakh, 5 lakh or a 10 lakh drone, the cost of the materials is only, the components only that maybe 10%, 15%, max 20%. 80% of the value comes from the licenses, from the software, the brain part, which Indians are blessed on. So I would suggest we focus more on the brain part, and the component side. Yes, we are working, but that will require some time because we need the critical mass. Ravi?
Perfect, Amber. It was electrifying speech and then great motivation. You know, in this COVID era, entire aerospace sector is going through the turbulence. There is one silver lining that is out there is drones. And the government and from you did a fantastic job, phenomenal for us. And it's inspirational for all of us. On behalf of SAE India, SAE International, I thank you for taking time out of your busy schedule and giving this wonderful speech. Thank you. Thanks a lot. Wonderful.
Thank you very much, Mr. Ambir Dubey, for this wonderful keynote speech. On behalf of the organizing committee, I would like to thank you for taking time out to deliver this keynote speech. We now welcome you to the panel discussion on disruptive technology in aerospace and aviation. I'm privileged to welcome the panel moderator for this session, Professor Ravi Rajamani. Professor Ravi Rajamani is an independent consultant and visiting faculty at the University of Connecticut. He is working on various model-based analytical technology in aerospace, other complex engineering domains. He worked at GE, UTC, Megad in the past before striking out his own. He is active in aerospace standard development, mainly with SAE. He served as the editor-in-chief of SAE International Journal of Aerospace and has been elected a fellow of SAE and of IMAC-E. He has authored 6 books and has several patents and paper his name. Welcome, Professor Ravi Rajamani. Now, let me introduce all the panel members for this session. It is my pleasure in welcoming Dr. Parimal Kopadekar. Dr. Parimal serves as the director of NASA Aeronautical Research Institute. He is responsible for exploring new trends and needs related to aviation in the area of autonomy, aeronautical manufacturing, and advanced air mobility. He also serves as the NASA Senior Technologist for Air Transportation System, Principal Investigator for the Unmanned Aircraft System Traffic Management Project. He is the winner of 2018 Samuel J. Heyman Service to American Medal in the Promising Innovation category. He has published over 50 conference and journal papers with 3 Best Paper Awards. He delivered many keynote talks at national and international conferences. He is the fellow of American Aeronautics and Astronautics and the recipient of numerous NASA awards, including Outstanding Leadership Medal and Engineer of the Year. I now welcome our next panel member, Dr. M.K. Padmanabhan. Dr. M.K. Padmanabhan is an aerospace engineer with more than 35 years of experience in education, applied research, enterprise creation, management, governance, and policy implementation. He is the director of Virginia India, Center for Research and Education. Prior to this, he spent 20 years with Indian Space Research Organization and the Aeronautical Development Agency, Government of India. He was also the CEO of Mahindra Aerospace. Our next panel member is Mr. Tom Plumer. Tom Plumer is a co-founder and CEO of Wingcopter and listed in Forbes 30 under 30. He heads the Wingcopter business development and he is a driving force behind the company strategy. His vision center around the global implementation of civilian drone technology, enabling the economic growth and improvement of living conditions. Wingcopter has entered a partnership with organizations such as UNICEF and UPS to make drone delivery feasible for both humanitarian and commercial use. Our next panel member is Mr. Sridhar Dharmarajan. Sridhar Dharmarajan is the Executive Vice President and Managing Director, Hexagon Manufacturing Intelligence India and MSC Software Indo-Pacific. He is the responsible for India's sales operation of metrology and the production software portfolio, as well as MSC Software and QDAS. He is responsible for company's market leadership and 10x growth. Our next panel member is Dr. Rob Harwood, Global Industry Director of ANSYS. Rob obtained his PhD in 1998 from University of Sheffield in the UK. Rob has focused on creating significant customer value through the industrial application of simulation-based engineering. Today, Rob leads the global industry team at ANSYS that focus especially on the automotive, aerospace, defense, energy, healthcare, high-tech, and industrial equipment sector. Welcome to all the panel members.
Okay, welcome to this panel on disruptive technologies in aerospace and aviation. I'm joined by a wonderful panel who will tell you a lot about drones and other technologies that we'll see in the future. So what I'm going to tell you today is very briefly what the history of aviation related innovations is and how the transitions into what you will hear today from the panelists. This slide is based on the work that Steve O'Flaherty, a good friend and colleague, did on recording the disruptive technologies in aviation for the SAE IVHM steering group. You may not believe this, but innovation in aviation started way before the Wright brothers. In fact, in 1883, somebody in France hooked up a propeller to an electric motor to batteries and actually introduced electric propulsion to aviation. But certainly, the biggest innovation in aviation was the heavier than air flight that the Wright brothers were responsible for in early 1900s. In fact, according to some people, there have only been about 2 or 3 major innovations in aviation. The next one is the gas turbine, with the research on which started about in the 1930s. But with the only after the war, the Second World War, was there commercial usage of the jet turbine, and that actually opened up the world to commercial aviation. The next innovation, according to some, was fly-by-wire, where instead of cables, you actually use electric signals to control surfaces and other and do other control functions within the aircraft. So that was a big innovation. But now, with all that, we are into the third or the fourth revolution in aviation, which is electric aircraft, drones and autonomy, and also on the softer side, model-based design, model-based certification, and the entire digital transformation. In fact, the use of AI, which has grown by leaps and bounds in every other sphere of life, is also coming to aerospace. And there is a new committee that SAE has set up called G34, AI in Aviation, that will be dealing with essentially certified artificial intelligence controlling our aircraft in the future. And clearly, you can well imagine that drones and autonomy would be a big application for AI. The other big thing that you will hear today is model-based design, model-based certification, and digital transformation. This goes not only in the operations, but also, obviously, in the design and manufacturing as well. You will hear a lot about that today, and that is something that we have to look forward to in the future, because that will certainly cut down on the time needed for design as well as certification, which is one of the biggest and the most expensive part of aircraft design. With that, what I'd like to do is to invite Dr. PK from NASA to give his talk on drones, autonomy, and how that's going to transform our society. Thank you.
Well, thank you, SAE India, for inviting me. This is really great privilege to be here and give you information about what we have been doing at NASA as well as industry at large in the United States. So let's think about where the future is headed. And I'll start off with an example of a summer internship project we did. We had a number of summer interns who connected the farmers with food bank via aviation. By that, I mean that during the COVID, the farmers were not able to find enough people to work on the farm and transport the products that they were producing, vegetables and fruits. At the same time, we had situation where the food banks were in over demand. And we needed to make sure that the farmers' food is not wasted and the food banks are getting adequate supplies. But the distance between the two were so large that it was difficult. So our summer interns connected the farmers with food banks through aviation. So they were able to send in 200 plus boxes of fruits and vegetables from a runway that was near the farm and runway that were closer to the food banks in the remote parts of California. That ended up being a really good example that demonstrates the promise of aviation in the future. Now you can just imagine. You can imagine that if the aviation industry were to reach everywhere in the corners of United States or India or any other country, how it could transform the future, the living and the businesses and the farming, agriculture. You can imagine that if every parts of any country is connected by aviation, either by drones or by quieter aircraft where the acceptance will be easier because of the new technologies based on the electric propulsion that gives you the low noise footprint. If that happens, you can imagine that people and the businesses can locate where it's optimal for them and then use the aviation as a mechanism to transport goods, services, and people. Today, what happens is we tend to live closer to the transportation hubs so that we have access to transportation to go to work, to go to some other places, and so on and so forth. But in the future, we could live or locate businesses anywhere and then have the transportation reach to you. So you optimize the living and the business location, and then transportation would be the one that connects you. That is the real promise in the future of aviation. That changes the way we would live, the society could possibly function. In order to get there, there are a few things need to happen. One is very quiet aircraft, smaller footprint for electric vertical takeoff and landing. And there are a lot of other options available. Hybrid, hydrogen being examined and other options, and things like that. So we need to look at those. But fundamentally, we need to make sure that the vehicles that will operate in these regions will be quieter. Second, the vehicles have become smaller. The typical aircraft that used to be is much smaller will be much smaller in the future with drones as well as the vertical takeoff and landing type vehicles. Once the vehicles get smaller, the noise footprint is lower, it's easier for communities to accept them, and you can reach into many parts. In order to get there, NASA is looking at a number of things. So the three main items that are important is the requirements for aircraft to operate in either urban or rural landscape. You want to be able to operate these aircraft with low noise footprint, with or without GPS, make sure that we have simple cockpit and simple aircraft to operate. So it doesn't require lots and lots of training that it does in today's world. So aircraft is one side. The second aspect is the airspace. We want to make sure that we do not burden the current air traffic management system so that we can scale these operations. And the third is infrastructure. If these vehicles are electric, you need to have an electric grid that is able to charge them at the vertiports and such. We also need vertipads at the locations that are easy for people and businesses to access to. So aircraft, airspace, and infrastructure, those are the three segments that all need to come together. So we built something called Urban Air Mobility Maturity Levels, UML, that tracks the progress on each side. So aircraft that's certificated, by the civil aviation authorities, airspace system that's able to give access to these aircraft as well as scale them, and the infrastructure requirements. If all of them move together, then we are going to be able to transform the aviation and could be possibly societies and businesses in the future. We have number of types of aircraft that are available at our disposal. Small aircrafts or the small drones, 55 pound and below, which are able to do infrastructure monitoring, deliveries of small goods, search and rescue, highway monitoring, and all kinds of things, and disaster relief support and such. So those are the small aircraft. Then you look at the mid-sized to larger aircraft, you can see that you can carry people through this vertical takeoff and landing type operations and goods, agriculture or manufactured goods. And then the larger ones they would need the runways. But even then, if you think about it, if we go towards electric propulsion, the need for longer runway might be reduced. Currently, the runway length depends on the weight of the aircraft and the distance it takes so that you can get enough lift. With the electric propulsion, the battery, whether it's charged or discharged, has the same weight. So you might be able to shorten the length of the runway. That also allows you to have airports in many parts of the country that will allow you to reach to many parts of the country by aviation. So fundamentally, in 20 to 30 years from now, we could be looking at a totally different transformed society. Now, one of the things that need to be in place to get there is making sure that this is affordable to everybody. In order to make sure that that's affordable to everybody, that there are a number of things that need to be considered. So the costs related to the aircraft development, costs related to manufacturing, the supply chain, the maintenance, repair, overhaul, the pilot training, the maintenance, all of those need to be considered. And countries like India can get into the manufacturing for sure, but the MROs, maintenance, repair, and overhaul, will be very much a regional phenomena because you have these drones as well as these larger vertical takeoff and landing vehicles operate at the regional and local level, and you would need to maintain them and repair them and overhaul them at the localities where they operate or near localities they operate. On the other side, you want to make sure that the aircraft is as simple as possible so that you can train faster and be able to get certification for pilots. In the long distance, it will be autonomous. So if you look at the different stages in which it would go, currently it's the drones, even the larger drones that are unmanned, are one-to-one remotely piloted. So from remotely piloted to remotely managed, where more software assumes the responsibility for operating that vehicle. Then it will go towards autonomous, and then still one-to-one, so human is still able to get engaged. And then over a period of time, it's end-to-end, so many vehicles to fewer operators, and there is interchangeability between vehicles and operators. So the economics works really well in the favor of operations that are affordable if we are able to get to end-to-end type of ratio. And that's kind of where we are headed in terms of making sure that the future of aviation will not only be omnipresent and pervasive, but also affordable and economically viable for businesses and people like you and me. Thank you for inviting me again, and look forward to having further discussion.
that was a wonderful talk, PK. I'm going to now turn it over to Dr. Padmanabhan to give his talk on drones and swarms of drones, which is going to be a very interesting discussion.
Good morning and good evening, depending on the time zone where you are in. Drones have been around for more than 2 decades, but the last few years have been significant in terms of their adoption, usage, and global awareness. While drones are designed to perform various tasks independently, the recent innovative approach based on swarm drone deployment technology, wherein a number of drones flying together perform multitude of tasks in a well-coordinated collective environment. In this presentation, let us look into some of the aspects relating to swarm drone technology and its applications. Just as a way of introduction, I am part of the US-based Virginia Tech, which is a land-grant university started way back in 1857. Virginia Tech Foundation has set up globally one center each for research and innovation for each continent. Among other areas in which we work at Virginia Tech India Center, our Aerospace Center works extensively in the design and development of drones for various applications. These drones design and development activities envelop technologies that include artificial intelligence, autonomous systems, and robotic communication network. Some notable projects that we are working include bilateral national programs in the areas of UAV with Korea and Spain. World over, swarm drone technologies are used in a number of applications. The oft-quoted ones include blended wing swarms used extensively for survey, the demonstrated 2018 Winter Olympics function of the Olympic rings, and the notable work by MIT demonstrating decision-making capabilities, adaptive formation flying, etc. Due to paucity of time, I would dwell on one swarm project that we are working on to support a search and rescue mission as part of the larger initiative of humanitarian aid and disaster relief. This formation, called the leader-follower strategy, is unique for multitask missions. Here, the overall takeoff weight of the drone is around 16 kgs, and it supports a payload of 5 kgs. The endurance is typically around 45 minutes. From the ground control system, the communication is through a data telemetry connectivity. The connectivity between the master follower uses an ad hoc network using Wi-Fi communication. Here, we have presented the overall envelope that is covered and the flight path that is set for such a coverage. There could be situations wherein there is no GPS. Under such conditions, with the help of satellite maps and the triaxis IMUs and magnetometers, the navigation is facilitated as shown in this slide. Just before we get to do field testing, we simulate the entire environment using a gazebo simulator in the laboratory to ensure that every mission that we want to perform are perfectly carried out. Then we obviously go to the field testing, where a significant amount of activities are involved to ensure that the mission is successfully carried out. Human detection using computer vision models is trained using neural networks. This helps us to locate people or any target autonomously and drop the payloads in a more precise manner. There are a number of other applications that one could visualize, which include network connectivities, anti-drone systems for civil aviation and defense, applications for agricultural needs, and urban patrolling, just to name a few. You could see that the promise of UAS is immense, And penetration of this disruptive innovation in various spheres will spur a new technological breakthrough in aerospace sector. As members of this fraternity, let us all eagerly look forward to this. Thank you and all the very best.
Thanks a lot, Dr. Padmanabhan. That was a wonderful talk. I'm going to next turn to Tom Plumer, who's the co-founder of and now the CEO of Wingcopter. And he's going to tell us about the work, the wonderful work they're doing in developing, manufacturing drones, and also how they're going to use that for delivering medical supplies, for example, and other applications.
My name is Tom Plumer. I'm the CEO and co-founder of Wingcopter, a German drone manufacturer and service provider. And I'm happy to be featured here at Aerocon 2020 to talk about the development of drones as well as the challenges and the opportunities. Now, a quick flashback on the history, and I'm sure in the audience, basically everyone will know, so I keep it short. So we had multicopters pretty efficient in takeoff and hovering, however, reduced the flight time, range, and speed. We had fixed wing systems in the past getting popular because they could fly really long, fly very far, fly very fast, but normally they needed a runway to take off or a catapult to be launched, which is complex and expensive, as well as catching in a net or with a rope or different kinds of methods to get it back to the ground, which were too complex and again, until today, are pretty infrastructure intensive. So the idea was, can we not create a drone which basically combines both types? By now today, everyone talks about eVTOLs. There are big ones, small ones, concepts in all directions for even manned aviation, air taxis, as well as the small SUAS or the small UAVs for all kinds of applications like agriculture, surveying, mapping, surveillance, but also delivery. And eVTOL drones, I think, are perfectly designed for drone delivery, for long-range BVLOS application, commercial BVLOS application. So yeah, we basically designed our system in 2012. We patented a so-called tilt rotor technology, which we're able to transition the rotors 90 degrees after takeoff, and then within seconds, switching between these two modes, multicopter and fixed wing. And I can speak from experience because we tested the system in multiple countries. By now we are operating in or having customers in 11 countries. We are looking forward to expand to India. So I'm happy to be here today to also look for partnerships. So I'm happy if you contact me and we talk about this opportunity to work together. So we tested the drones in different environments and we made sure that different methods of deliveries were tested. So we had with DHL, for example, a partnership where in Tanzania, we delivered over a range of 65 kilometers from the mainland to an island called Ukerewe Island in Lake Victoria. So we were delivering medicals and it was a bidirectional delivery, which means that we were flying one way, delivered medicals to the remote hospital from the medical stores department. And then we swapped batteries, we put in a new payload, which means value on the way back. And we sent the drone to the rooftop of a hospital on the mainland to deliver laboratory samples to get analytics faster. And it means we reduced the waiting time for patients drastically, and we could use the drones on both ways. We also tested drop deliveries, which means one-way deliveries, where we have a certain small hub, very cost efficient, or basically very easy to operate, as you just need someone who pre-programmed the routes, the drone automatically takes off. And whenever there's an on-demand request, for example, in Vanuatu, where we work with UNICEF and the Ministry of Health of Vanuatu, we were one of the first people delivering vaccines in the world. So with eVTOL Wingcopter drones, and we use these drones to fly to a village. We actually served 19 different villages on demand. So whenever there was a call from a nurse, we were flying the drone to that village, and we didn't need to land because it was child vaccination, 50 in one flight. So 50 in the payload, sending in on one flight. And then children were all around at the hospital entrance. So you cannot land really with the drone so far away, BVLOS. So we made sure that the drone is hovering, lowering the package on a winch mechanism we invented, and making sure that we accurately drop the package. So that was one-way drop delivery. And we proved that even these villages were extremely remote, and before you needed 7 hours of walking, we flew there in a few minutes, delivered the package, the drone turns around, comes back, can be reloaded and sent again. However, despite all these great things, and actually one more thing, we are using the technology today for COVID response. So we have just lately worked in Scotland with Skyports and Thales to deliver first protective materials to a far away or hard to reach island hospital. We have also used, and now we are preparing actually our technology for vaccine deliveries. When we look at COVID vaccine delivery, where millions of doses will be delivered in the next couple of months once it's ready. And we want to work in this space, and therefore we prepare even now mass production on the drones, so we can really have hundreds of drones ready or even thousands of drones ready to fly. However, there's a public basically acceptance problem. There's still, apart from the regulatory part, and we have the professionals here who can talk about this, so I leave it up to them, but I can say that we need to be more proactive. Even though I like the Digital Sky Initiative and the no permission, no takeoff idea, I think we need more proactive rules, and we need to make sure that, I think for safety reasons, regulatory is perfect and policies need to be made, but in a way that eVTOL drones, and I can't see them in India yet, we wanted to fly, we were selected as one of the 13 consortia to fly in that BVLOS granted, or we granted access for BVLOS flights in India just lately as one of the 13 teams. And we are not able to fly a wingcopter in India because eVTOLs are not allowed, at least not the ones we are using. So I would be happy if India allows these eVTOLs to come, so we can make sure that we can fly delivery safely and efficiently. I think, again, looking at public acceptance, it's still a noise thing, but eVTOL drones have the benefit that once you take off and you transition, for example, to drones, it flies really silent. On the privacy and data issue, the whole sense and avoid is already working pretty well without capturing the data and keeping it on the drone. It's just analyzing the laser or a downward-looking camera, which just like records, but not for saving, but just for understanding the surrounding and making smart decisions on its own. I mean, in terms of the whole autonomous flights, we are still at one operator, one drone policy right now, or basically that's where the technology is. We are looking forward, and this is what Wingcopter is also working on, to have like one operator, 5 drones in the air, or even 10 or 20 at the same time. So this is the direction where we are heading with drones in future. As drones now, the whole acceptance is growing. Actually, it's not just about the noise and data and the privacy issues. It's really also positive things like COVID accelerated the acceptance as people understood that we have to reduce human interactions. So delivering food without touching it or really just putting it in the drone and sending it off, it's much more safe in COVID times than touching it and deliver it face to face. So basically, that's something we see drones are actually on the positive. That's the chances of drones now. Despite aircrafts are grounded during these days of COVID, airlines really struggle hard. I think the really next big step, and we can talk about this, even airlines could start a new business in this drone space. That's why we're looking for partnerships. And I think it's really the idea to now combine general aviation with the drone technology. And the regulatory framework needs to be like constantly improving so we can make sure that safely and environmental friendly drones can be played to the air and really make sense for improving and saving lives on a daily basis. So just to wrap up here, I think in future the level of autonomy of these drones will raise, because right now it's still not, we cannot talk about autonomy really, it's pre-programmed flights, automatic flights, but this will really change. As I said, multiple drones will be operated by just one person who is controlling them, more for safety reason. I see also the scale and size of the drones, where we will be able to carry kilos and even tons of payload with drones. So it will help us in our everyday life to use the time more efficient and really use the time for our families, for our like lives, and not to spend time in the car, you know, like polluting the air and all this. I think drones really will make a difference. First, the logistic drones, and later on the manned drones. So I'm looking forward to this exciting future. Happy to could speak a little bit about this. There's so much more in terms of like how we pioneer these days. And I think with the drone industry are where cars were 100 years ago. So we have all this bright future ahead of us, but luckily we are working with electric drones. So hopefully not that polluting the environment. And still, I would say I'm happy that you all listened, and I'm happy to meet you. See you in a minute, and welcome again to AeroCon 2020.
Thank you, Tom. That was a wonderful talk. I'm going to now turn it over to Sridhar Dharmarajan from Hexagon, and he'll tell us about the digital transformation of the aerospace ecosystem and how Hexagon is helping in this transformation.
Good evening. I'm privileged to be part of this panel discussion discussing on disruptive technologies in aerospace. So if you look at it, the topic of my presentation is cognitive engineering evolution through smart manufacturing. Just to give you a brief on Hexagon, what we do. If you look at the Hexagon tagline, we are in the business of empowering an autonomous space of the urban space. So we are in the business of creating smarter industrial facilities, smart manufacturing, smart mining, smart agriculture, smart mobility, smart buildings and infrastructure, smart cities and nations. We are the leader in design and manufacturing space worldwide. To give you a perspective, Hexagon technology touches about 95% of the vehicles produced, 90% of the aircraft produced today, and about 85% of the smartphone produced today. We recently saw a paper from Capgemini which spoke about the quality improvement and the productivity improvement. The compounded annual growth rate over the last 30 years has only been about 0.44% in quality and 0.74% in quality. I repeat, in the last 30 years, the growth in quality has just been 0.44% and productivity 0.74%. And the same paper predicts that in the next 5 years, our quality is going to go up by 5.13% and 5.04%, an increase of almost 12x and 7x. And this is phenomenal. And this is essentially happening through the smart factory initiatives that the whole industry is taking. And I really want to brief about how Hexagon is working here. So Capgemini also predicts that by the end of 2023, there's an increased productivity adding up to about $1.5 trillion to the global economy. And this is a great opportunity for manufacturing industries not to really miss. There are some challenges out here. Currently, they say only about 14% of the companies have been successful in implementing these initiatives. And I just wanted to elaborate what are the essential gaps that we are seeing here. So the gaps essentially the IT/OT convergence, whether it including the digital platforms and integration, a range of skills and capabilities that is really needed to drive smart factory transformation. So we need to ensure that we reskill, upskill our employees in the organization. The cross-functional profiles connecting not just engineering and manufacturing and intelligence, but taking the various silos in the current manufacturing industry. How can we make each of these silos digital? And how can we infinitely connect these different silos so that the whole organization behaves like an organism? And these are some of the things that we need to do to integrate all these divisions to come up with the product, get it right the first time, and get it right in the shortest time that is really kind of possible out there. So how do we do a cognitive learning process today? And if you really look at the different parts of the brain, there are certain parts of the brain works on the predicting space, certain part works on the acting space, and certain part works on the inspecting space. Can we really replicate these to improve our product quality and the process? And that's what we're going to talk about. So how do we achieve the full potential of Industry 4.0 for design and manufacturing? If you really look at the traditional automation pyramid, we have the field IO, the SCADA, the MES layer, and of course at the high level, the AI and the ERP PLM layer. And we need to take this automation pyramid as a base and convert it into a smart manufacturing pyramid. So we have to add the digital process transformation, the smart manufacturing technology, and have this whole cognitive engineering evolve from this. And this is what I call the smart manufacturing pyramid. And how do we do this? We need to really focus on the entire organization, whether it's the design and engineering department, the manufacturing department, or the quality department. So what is really the quality of a part? If you really take the part, there's a perceived quality and a performance quality. Perceived quality is essentially how does the part look like? What's the surface finish of the part? And the performance quality is how does the part behave to the various conditions that is facing the external environment? Is it really behaving as per the specification that is put up by the design and engineering department? So the design and engineering department may say that I've designed a great part. The manufacturing department may say I've manufactured a great part. The metrology department or the inspection department or the quality department will measure it and tell you, boss, the truth of the pudding is in the eating, and show you what are the tolerances of the part. So essentially, can we connect all these divisions through a digital thread and learn from all these divisions and finally get it right the first time and also get it right in the shortest time that is really possible? So essentially what we're talking about here is to connect the physical world and the digital world. So the smart factory within Hexagon targets the integration of IT, OT, and simulation technologies to create a highly competitive manufacturing environments meeting the demanding application requirements of the factories of the future. Integration is multi-directional. In this process manufacturing, you will not only need to capture the OT data from the PLCs and the data historians, you will also need to contextualize it with the data from MES, ERP, quality management systems, name the few. Above all, you will want to ensure that the platform considers the production processes in its data schema to accurately reflect your production processes in addition to the assets. So we need to contextualize the hidden data. We need to take care of the data-driven value drivers, digitize and enable the company-wide BI, move data from where it is created to where it really adds value. So we connect this physical world to the digital world. So we need to ensure that both are seamlessly connected. So we manage to help us to manage the data during the entire product lifecycle, but simulate in the entire digital twin to improve and enhance production. So if you take the digital world, whether it is a product lifecycle management, the design and engineering, prototyping, production simulation, assembly simulation, analysis and correction, and we need to connect both, seamless connection of both these physical and the digital world. And that's why I call Hexagon as a phygital company, where it is not only has the hardware for the physical world, but also has got the software for the digital world. How we can fuse both these worlds together to ensure that we drive efficiency and productivity in the organization. So if you look at it in the physical world, we have the performance testing. Whatever you designed and simulated in your digital world, you can actually test the part, you can produce the part, you have the factory processes, finally you have the methodology to really measure the quality of the part. And then in the digital world, you have the design and engineering, validation, process validation, manufacturing, scheduling, real-time manufacturing, and analytics. So this is another example that I really want to talk about from the aerospace industry, where we have the design department. It could put the additive manufacturing, the machining department, inspection department, the quality, the operational departments. Finally, how can we take the augmented decision based on the data available from these various departments, and how do we connect the different divisions through a digital operation framework? And this will help us to improve the design for to reduce the defects or the maintenance requirement. And this is what I really talk about cognitive engineering evolution. So I'm taking one more example here, a specific workflow describing the comprehensive set of technologies that tackle the complete workflow of wing design, production and inspection, helping and to improve the efficiency of the factory. So with the smart factory solutions built using our Xalt technology, there are many opportunities to implement the feedback loops through this workflow to improve the efficiency, transmitting the wing inspection data to the aircraft assembly flow. Fitting the wings can be completed in the virtual world before the expensive and the time-consuming process of assembling the wings in the digital world, in the real world. Inspection data can be used to correct the manufacturing of the wings themselves, and the real-world experience can be leveraged in re-optimizing the design and virtually testing the performance of the wings. Every 10% increase in throughput of the year means a half-year quicker delivery, and this is a major benefit to the customer. This example is an example in the machine tools area. The machine tools are used throughout the manufacturing of the automotive powertrain components and many other components in the production of the vehicle. Optimizing the performance of the machine tools offers a huge opportunity in the automotive production. We have added the different and additional capabilities like Etalon. The first solution we have launched here is our machine tool feedback loop, in which the measured data taken on or off the machine is subjected to statistical analysis, and the results are fed back to correct the tool offset to maintain the productivity for longer before tool changes are necessary or needed, and also to maintain the quality. We have also built a comprehensive suite of technologies, including the machine workflow, including the machine collaboration using our Etalon product line, machine simulation using a Spring and NC Simul product line, the machine tool diagnostics, the tool management, offering further opportunities to develop feedback loops to optimize optimize the machine performance. Here's another example of how can we actualize the full potential of additive manufacturing, whether it is simulation of the complete additive manufacturing process, because these materials are very expensive. You have to get it right the first time, I've heard of an experience of a company where the additive manufacturing took about at the end of the 14th day, it failed and they had to restart the whole thing. And that's when they bought our simulation technology to simulate this whole manufacturing process so that they can get it right the first time. So this cognitive engineering evolution through smart manufacturing helps us to increase productivity, improve quality, obviously reduce cost, and improve safety and sustainability, which is very, very critical. So it's going to be a two-speed world going forward. There's going to be innovators who are going to take advantage of this disruption. They're going to use this disruption as an opportunity and start implementing some of these new technologies to increase efficiency, to increase productivity in their organization. And there could be laggards in the universe out there who would be slow in adopting these technologies, would actually kind of go down from the level that they're there today. So I would strongly encourage for all of us to be innovators. Let's choose to be innovators and implement some of these technologies and improve the efficiency and productivity to get our products right into the market the first time itself, and ensure that we get it right in the shortest time available, which will help us not only to improve our top line as well as the bottom line. Thank you so much for this opportunity. I'm open to any questions out there.
Thank you, Sridhar, for that wonderful talk. Finally, I'll turn to Rob Harwood, who's from ANSYS. He's the Global Industry Director for ANSYS. And they've been developing a lot of model-based design tools for many, many years now. Rob is going to talk to us about the digital transformation of the design space, of the design ecosystem. And he'll talk to us about process efficiency and how we're going to use the digital transformation to change and make the entire ecosystem and the value chain more efficient.
Hello, everyone. My name is Rob Harwood, and I lead the industry team at ANSYS, as well as having a specific focus on aerospace and defense. I don't usually use my photo in presentations, but as we can't be together in person, at least you can put a face to a name. I do hope everyone is safe and well in these incredibly challenging times. And let me express my sincere thanks to the entire team at SAE India, to the panel chairman, and to my fellow panelists for coming together and making this happen. I'm going to briefly touch on accelerating digital transformation with simulation. Now, digital transformation is not a new concept to this industry. In fact, in many ways, the industry is actually a digital transformation pioneer. As you can see here, based on these statistics, 2 years ago, Accenture reported that 97% of aerospace executives were willing to digitally reinvent their business and industry. And why would they do this? And why would they do this in such large numbers? Well, the benefits are very clear. A 15% increase in revenue and a 10% reduction in costs represent vast sums in this industry. And this is the type of quantified return analysts at McKinsey project. However, despite the enthusiasm and potential business outcomes that we just shared there, analysts tell us that at least in 2017, so this is pre-pandemic, only 7% had made substantial progress. And clearly, in the 3 years since this last research was done, I'm sure that figure has increased, but today the figure is still relatively low, certainly relatively low compared with the willingness to implement and the benefits that can be accrued as a result of implementing. And you don't need me to belabor the situation in the industry today. And you know, given the current perilous state of the industry, I would argue that accelerating this adoption has now never been more critical. And as I mentioned on this here, you know, the current state of the industry threatens to stall the pace of adoption. But while the magnitude of the current situation is indeed unprecedented, there are lessons we can learn from the past. After the last financial crisis, researchers at Harvard identified that 9% of companies come out of a recession stronger than ever. What actually do they do to achieve that? Now, obviously, I'm not going to, in the short time I have here, go through the detail of this report, but it boils down to two basic points. First of all, they focus on improving process efficiency, not just pure cost cutting across the board. They actually look at the processes and drive up efficiency. Secondly, They don't, again, just cost cut across the board, but they selectively actually increase R&D investment in those technologies that are going to future-proof them for when the situation ends, so they can come out stronger. So let's take a look at that, that first point, improving process efficiency. And I'm going to talk to one aspect of simulation here, because it's imperative that we focus on those aspects of digital transformation that can actually deliver near-term return on investment, because we're in a situation where protecting cash flow is absolutely business critical at the moment. So if you look at the impact, and these are quantified impacts from independent research by the Aberdeen Group, that when we look across the life cycle of a product in the aerospace and defense industry, what type of impact do we actually see? Well, if we think about the traditional design and development phase, we do see, and this is where a lot of people on the call here will be familiar with the impact of simulation, like, for example, the reduction in very expensive physical prototyping, like the fact that as a result of eliminating many prototypes, you can get to launch and production much more quickly than you can any other way. So you're making a big impact on how and where costs are committed in the product development process. So the value of those percentages is measured in the millions, if not more than that. And then as we move further downstream into actual production and manufacturing, and then post-release and into market, we also get substantive impact. And you see some of the numbers here: 26% greater overall equipment effectiveness, 23% greater raw material utilization. This is all about process efficiency. This is tying back to how can we become one of those 9% of companies. And then as you move out and beyond production, you're into operation and maintenance, just getting to that point, companies are substantially more effective at getting to that point on cost targets. And this is a staggering statistic: 79% of people are less likely to be concerned with recalls. The engineering teams are going to be less likely to be concerned with recalls. And you think about the economic impact of set-asides to deal with recalls, there's massive benefit to be had there. So simulation has a big role to play in that digital transformation impact on process efficiency. And of course, in the situation we're at right now, it's not just a matter of driving out cost and improving process efficiency. We have to reestablish as an industry the trust of the traveling public. So simulation can also play a very visual role and a very credible role in helping develop those technologies that are going to bring that trust back into the marketplace. And we know for a fact that simulation powers the innovation engine, even more so when getting lab access is increasingly challenging. So recent research, and I point to a report here, has shown substantial upfront benefits. So if you take simulation beyond its traditional detailed design and verification phase, and you move it much earlier in the design phase, you can significantly increase your ideation and how many iterations in the potential design space you can explore. So we're really starting to power the innovation engine. And that leads us into the fact that simulation is absolutely critical to solving the future challenges of aviation. So when we move beyond the pandemic, and when we've got, we're in the recovery stage, right? We're really going to be turning our attention to those safer, more sustainable aircraft, whether it's better aerodynamics, advanced materials and additive manufacturing, to lightweight, better propulsion systems, even completely alternate propulsion systems like fully electric or more electric aircraft. And all those future aircraft systems, whether it's vertical takeoff and landing, urban air mobility, where we're talking about increasing autonomy, maybe one day even full autonomy, and completely novel configurations of aircraft, and of course, maintaining the excellent level of safety that the industry has to date as well. So not only are we talking about process efficiency, rebuilding confidence, but we're really looking to innovate to come out stronger. And that just leads me directly into my concluding thoughts, where, digital transformation, simulation, these are not new concepts in the aerospace industry. But what's really important for us now is that in the near term, we have to focus on those projects that deliver quantified process efficiency improvements that have quantifiable cost out impact on the business today and can deliver the confidence that air travel is safe. In parallel, we have to continue to very selectively, very judiciously invest in those processes and technologies that will define the future of the industry. Simulation is a business critical technology, even more so today. Accelerating adoption across the entire life cycle is essential both to survive today and thrive tomorrow. So my message here in conclusion is let's make sure that more than 9% of companies come out stronger after this particular situation. So let me again just say thank you to everybody involved, to the organizers and my colleagues on the panel. Thank you.
Thank you, Rob, for that wonderful talk. Now what I'll do is I'll open it up to the audience so that they can ask us some questions.
Excellent. Yes. Thank you, panelists. It was a wonderful and insightful panel discussion. There are a lot of questions.
Can you hear me now?
Yes.
Okay. Sorry about that. I think I was talking all the time with my muted mic. So, all right. So I don't think we have too much time for questions here. Maybe one question that all of us can answer. And that question, we all know that our aerospace industry is a very risk-averse industry. So a question that came in from the audience was, what are the safety concerns in applying disruptive technologies in the aero industry in the future? So how would you address that? And I will start with PK.
Well, that's a great question. And I think one of the things we are doing inside NASA, and I think many others are doing, is looking at the corner cases and off-nominal conditions and contingencies. So, if the previous speakers talked about electric vertical takeoff and landing, or larger drones, or passenger carrying autonomous aircraft eventually, or at least cargo carrying autonomous aircraft. Look at corner cases and contingencies, and that those could be bird strike, engine failures, reserve fuel, all kinds of energy depletion, all situations like that, and understand how those will be handled in the context of mixed equipment, where there is manned aviation and unmanned aviation operating simultaneously in the same airspace. We really need to do a lot of simulations, model-based engineering, flight tests, and understand these cases, how they will be addressed, and that's what's going to give us confidence. Digital twin definitely helps in trying to promote that data-driven thinking. So, thank you for that question, and look forward to continuous development in this area.
Okay, I'm going to mix it up a little and ask Sridhar to go next. We won't have all drones. We'll have digital transformation next. Muted, Sridhar.
Myself, yeah, can you hear me, Dr. Ravi? Great. So I just want to say that how safe is always a question. We very readily accept failures from a human. Human must have done some mistake and it's acceptable. But if a machine creates a problem, or if a machine kills a person, then there's no way it's acceptable. So how safe is always a question, and that's a kind of a pressure on us always, especially when you're talking about digital transformation and you're saying that no people factory, everything is automated, or less number of people during this COVID time or whatever. So this is the way you can really address this. As Rob spoke so well about some of the simulations done in the engineering side. Today, you can do a simulation not only on the engineering side, but also completely on the manufacturing side. You can have a digital twin, whether it comes from the components or machines in the various factory floor, but also the entire process, the way the manufacturing is done. You can have a digital twin, and you can digitally see how the part is actually manufactured before you go ahead and manufacture the part. So I would say that today, a lot of simulation tools are available. And one needs to do more and more of simulation to ensure that they get it right the first time, and they also get it right in the shortest time.
Thank you, Sridhar. Thank you, Sridhar. You mentioned Rob. Maybe I'll turn it over to you, Rob, and ask you to go next.
Yeah, thank you. And I think it's a great segue from the previous comments there. And I'll keep this quite short to give the other panelists plenty of time. But when you think about disruptive technology, by definition, there is no design president. We haven't done these things before, because if we had, they wouldn't be disruptive. So without design president, how do you quickly build the knowledge, the expertise, and the experience that actually, when you do implement this solution, it will work first time, it will be safe? And I think with the complexity of technology, combined with the lack of historical design precedent, simulation is really the only way to rapidly build that knowledge. Of course, you still ultimately have to test and put these things out in the real world, but you build that confidence initially through massive exploration of the design space before you even enter that stage. And I think that's really the answer in the future that I see.
Can you pick up on that and see what you can do for safety when you have swarms of drones?
Is it me, please?
Yes, it is you, Dr. Padmanabhan.
Okay. See, actually, when we talk of safety, there are various things. And one of the things we're extensively working is the area of safety in operations, where the various stakeholders, the government, the private, and the suppliers are working. And the technology based on which we are working is on blockchain, where we need to collect a lot of data based on a number of flights, both on simulation as well as in flying, and use them extensively as we go along in applying them to real-life situation. The more and more data we collect, the more and more we analyze, the more and more we'll be able to build robust safety systems. And that's based obviously on new technologies. Thank you.
Dr. Padmanabhan, thank you. And finally, Tom Plumer. Safety must be a huge part of what you do. What kind of certifications are you doing? What are you doing for your drones?
Thank you very much for the question, and appreciate to be here. So I think the most important thing is, as you said, safety is first, and placing disruptive technologies like these new drones into the sky. I think it's a two-way. Apart from what has been said before, I don't want to repeat, but I agree. The things which have been said are correct. The other thing is, I think Amber Dubey referred to, let's test and learn, and even a crash can help us to improve, which for sure it has, if it happens to happen in a really extremely rural area or dedicated test corridor. So for sure before drones can fly, and I think this is sometime will pass until drones fly above urban space. We will need lots of testing, and I think there is another approach as well, looking at the manufacturing of drones. I think we need to get away from the model aircraft production to the aviation grade technology, which means really working on towards certification and redundancy. I think this is the major key in drone technology to make sure that there's no single point of failure in the systems. And I think there has to be done a lot. I think everyone in the couple of years, the last years, were excited building stuff. I think the first generation Wingcopter was pretty much a really nice model aircraft. And now we are moving into building a new production facility, looking at the next generation of Wingcopter drones as we partner, for example, with UPS. We have to be FAA conform. And therefore, we really work, and this takes 1 or 2 years minimum to make sure that you really have an aviation grade drone technology. And yeah, looking at redundancy, we are now adding lots of features to our current drone, taking the learnings of the last 5 years, which was testing. I think a lot of testing has to be done, and really also in the real world. So we would be really appreciating if more regulatories would allow like these test corridors. Like I really like the consortium idea, which is happening in India, that a few selected companies, and we are part of this. Unfortunately, eVTOLs and fixed wings are not allowed yet. So we are hoping to also be allowed to test, hopefully next year, with our Wingcopter in India. And then closely, for sure, with the regulatory bodies to ensure then safe regulatory framework, and then integrating commercially the BVLOS flights step by step. And again, yeah, redundancy, not model aircraft manufacturing, but really looking at aviation grade technology and being compliant with all the certification rules, which are out there already.
Testing, physical testing, and simulations go hand in hand in the future for sure. Hey, thanks a lot. What a wonderful panel. You guys are all experts in your field, and I think that came through, and I think the audience really got a lot from this. And I thank Dr. Ravi Kumar and the organizers of from SAE India for setting this up. I will hand it over to Ravi now.
Thank you. Thanks a lot, Dr. Ravi and the entire panel. It's very, very difficult to get your time in spite of your busy schedule. You have come here and taught us many of these disruptive technologies. It's a wonderful session. Thank you. On behalf of SAE India, SAE International, I thank you wholeheartedly. Thank you.
I would like to thank the moderator, Professor Ravi Rajamani, and all the panel members for very informative session on disruptive technology in aerospace and aviation.
That was action-packed 2 days. 34 speakers, out of which 13 international speakers, 4 different sessions, 15 months of efforts, 15 months since the dinner meeting with Murli in Bangalore, 12 months since the formation of SC brainstorming meeting, 10 months since the formation of OC, and we would like to give the off the screen and on the screen efforts. It'll be someone who carries Aerocon as his fuselage. Yes, ladies and gentlemen, that will be Mr. Muniratnam. Mr. Muniratnam is an aeronautical engineer with a postgraduate diploma in management. He began his professional career in HAL and moved on to engineering services industry in early 90s. He has worked on many international projects in Holland, US, Germany, and a few other countries. He has moved from technical roles to customer interfaces and business development to manage the pan-European operations on engineering services. He was a country head of DSQ. During his tenure in Germany, he BMW, Audi, and IBM, to name a few. Muni is a multifaceted volunteer in SAE India. He is the chairman of SAE India Aerospace Board, now called Aerospace Forum, member of NASSCOM's SIG in A&D, founder president of Infinite Association of Indian IT Companies in Germany. He is a recipient of Dr. KCG Excellence Award for distinguished alumnus from Hindustan Group of Institutions. He is the founder CEO of Java GM Consulting, which focuses on cross-border activities in engineering. May we now invite Mr. Javaji Muniratnam on stage to sum up the efforts off the screen and on the screen of Aerocon 2020. Muni, over to you.
Thank you, Venki. Thanks for the very interesting introduction. Good morning and good afternoon and good evening to all the delegates who have been patiently listening and participating for the last 10 hours, yesterday and today. Just would like to step back, like Venki said. Just wanted to give a brief evolution journey of what we have been doing the last couple of months to arrive at this final day. The thought process came that all the aerospace forum leaders thought that we should have an international conference in India. It should be world-class aerospace conference. So we felt that, okay, how do we start that? Initially, we had some meetings. And interestingly, when we had this meeting about 15 months back, absolutely scenario was different. We all felt that, okay, we need to book this big hall, we need to invite so-and-so, logistics, all that we have discussed. But as things progressed, I'm sure all of you know that things have progressed dramatically. And the event was changed from physical to hybrid. We thought that, okay, maybe in some cities we'll have a physical presence. In some cities, we will have a virtual presence. So that was the thought process. Then obviously things have changed and becoming dramatically challenging. What we did was, okay, let's all go typical virtual. But thanks to our forum leaders and all the committee members, we said, okay, can we be different? Because aerospace has been always be a technology forefronter. We have been adopting technology the best. So why don't we try, even in SA India, why don't we try a different approach? That's why we have actually jumped into this virtual 3D conference. I'm sure for all of you it have been, maybe for some of you it is a first time experience, but at least most of you have seen this in a different format. So having said that, a lot of deliberations took place. We formed different committees, excellent committees. In fact, outstanding members from each of the committees, whether it's a steering committee, whether it's an organizing committee, and most importantly, the technical committee. Having said that, office team has always been behind us, supporting, thanks to Mr. Venki and his team. So in the last 2 days, I'd just like to cover briefly. In the last 2 days, it has been an excellent journey. When we started, we felt who are the company we need to invite, but finally we actually successfully ended up having OEMs, the top OEMs, top tier ones, MROs, tech solution companies, engineering services companies, regulatory authorities, and academia. I think an excellent confluence of people from A to Z of aerospace journeys. So we could get them, and interestingly, the speakers have come with a very, very rich experience. World-class leaders in their own organizations, traveled the entire journey of their thing in aerospace, and minimum, 15 years to 40 years of experience. Speakers have been on the board for this event. And I would not touch deeply into what all we have discussed because I'm sure all of you have attended this. But very briefly, I would like to touch that kind of topics we have dealt so far was that what are the design challenges considering the COVID scenario? What are the future digital solutions possible? And evolving manufacturing scenarios, supply chain impact, and possible solutions and its learnings, and operational challenges. And interesting, we also touched upon regulatory aspect. In most of the seminar, we just simply focus on the technology set, but we have touched upon the regulatory aspect as well. I think the icing on the cake is Mr. Ambar Dubey's insight information into our drones. This is what we have discussed. And thanks to him for having given the actual scenario of what's happening on the ground with regard to drones, regulatory aspect, the government support is an outstanding information, has been an outstanding speech as well. And during this conference, very interesting to have noticed that many myths, I wish actually not only the aerospace fraternity in India and abroad have joined, but I wish even some of the common public, I wish they have attended this session, because some of the myths have been literally broken now. One of the speakers excellently highlighted how air travel is the safest. It has been always the safest. All of us know that air travel is the safest, but even today, even now in this pandemic situation, air travel in terms of the air circulation, how it is being maintained in aircraft, the outstanding speech has given, it clearly shows that air travel is the safest. That means you can given the confined zone, but you're really safe. And interestingly, he was also given another fact that social distancing is also possible because the way aircrafts are designed, the ventilation aspect is taken care and all that. And more than any other location, whether it is the shopping malls or the cinema theaters, but the entire airports have managed well to see that air travel right from the day you, before taking the, as soon as you enter the airport, taking the boarding pass, entire journey of you into the aircraft and outside the aircraft, that has been extremely covered by some of our speakers. It clearly demonstrates that air travel will be the safest and is going to be the safest again. So there's another interesting aspect we came to understand is out of all these speeches. See, digital implementation always feel that is a big challenge. You go to your CFO, CEO goes to CFO and saying that we wanted to implement this digital solution. This is our CapEx budget. But always it's a question. But it has been a big challenge. Besides the best technology solutions available, like most of the speakers have spoken, but it has been proven during this entire 2-day session that digital implementation is the solution, and it has become easier and better. And it is proven that this is the time we have to really experiment much more. I think this is excellent input what was given. And most importantly, again, coming back to Mr. Dubey's speech, all along, generally we have a feeling that government, only talks, but reality is different. But he has really shared what's happening on the ground realities and how quickly it is happening. I think this is a great information for all of us. I'm sure all the participants who have patiently been listening to us for the last 2 days have been well received, all these things. Once again, thank you for all the participants and speakers and sponsors, everybody. That, of course, my rest of the speakers will take it over. Thank you, Venki. And have a nice evening. Be safe.
Thank you, Muni. I think that was a quick sum up. You have well said, well summarized. Ladies and gentlemen, the next speaker we're going to call is the digital prophet of Aerocon 2020. He and his team has put together a lot of work for the Curtain Riser event and beyond in making the digital strides into SAE India. Damodaran Subramaniam is the steering committee chair. Currently, he is the managing director of Saffron Engineering Services. He started his Saffron career as director and served on several transnational projects. Over to you, Damu.
Thank you, Venki. It was a fantastic program. You managed to pull, like it's a 15 months dream. What I added is only a digital accelerator, but the groundwork was really amazing. It was a great opportunity for us how to reinvent ourselves using this digital technologies. So it was fantastic. We did a curtain riser in a very quick note, but much in a large scale with the 3D, with the collaborative environment, bringing all of them into the digital platform. It gives a lot of motivation for the struggled community how to move forward. I think this is going to be an energy booster for all of us to gain confidence, and all the topics has been fantastically selected and orchestrated. Thanks to the organizing committee and technical committee and marketing to really make sure that the digital platform, it's only a platform, but the content was well managed. And I really appreciate and thank all the participants, all the panel discussions will be a very good knowledge repository for us. I like this to be available for the participants to see whenever they want. Thank you once again for a great opportunity for me to be a part of this team and give some suggestions to steer this program. We had a very, very heated arguments and challenges in order to deliver the best. I thought this is only possible in our aerospace programs, but running this event also really challenging. Thank you very much, Venki and the team. Wonderful job.
Thank you, Damu, for all the support and the digital strides and the digital guidance. I think SAE India got transformed because of your continuous push. Ladies and gentlemen, the next speaker we're going to call is the one continually pushes SAE India's bar high and high. We are now closer to the sky. due to him. The executive who gives igniting ideas for India, an executive with an exceptional ability to persuade his team members. We could not have thought of any other leader who can offer us the torch and the lights to move forward. Ladies and gentlemen, join me in welcoming President of SA India, Dr. Bala K. Bharadwaj. Sir, please give us, audience, aerospace leaders gathered, the way to move forward. Over to you, Dr. Bala.
Thank you, Venki. I'm glad you are still talking to me and you didn't give up on me. Good evening, everyone. Good morning, good afternoon. I know we have an international audience here. I'm actually absolutely thrilled that we have come to the end of this program in very good shape. But before we talk about the program, Venki kind of gave you a hint. Don't know if it was intended or not. You know, Muni and Damodaran talked about how we got, what were the challenges in getting this program going. I'm going to ask you to do something, think about something different. Where do we go from here? You know, 2 days, we have talked about a lot of interesting things, a lot of interesting aerospace related things. But I mean, you can feel good about it, but then talking is not enough. You have to go beyond this. But before we get there, I do want to express my gratitude. You know, a lot of speakers, a lot of experts who have come and shared their knowledge, their, you know, perspective, you know, with the audience. Thank you to all of them. And if you are sitting in the audience, I don't know about you, but I found the session yesterday a little bit challenging because of some technical challenges. I hope you didn't have too much difficulty, but today things went well. So thank you for being with us. Like Damodaran said, I think this material will be available for some time at least. In case you want to go back and look at a presentation, please do. And I absolutely want to thank our sponsors and our volunteers. A lot of people have worked on this. But really, I want to talk to you about where do we go from here. And in order to do that, I think you will agree with me that aerospace industry, aerospace as a profession involves a lot of complex topics. We have been able to cover part of the flight envelope. You know, it's a large flight envelope. We've only been able to cover part of it given the constraints. You have 2 days. And of course, we are not sitting in front of our computers for 8 hours each day. If it was a real life conference, maybe we would have done something a little bit different. So there are topics that we have not been able to touch. And for example, one big topic we really did not get into is the world of military aerospace. We talked a lot about civil aviation, you know, how to travel safely and the digital impact and all that. But we really didn't say much about the world of military aircraft and military, you know, applications of aerospace. Very big area indeed that we have not have a chance to touch. The other thing we have very briefly touched is the skills. You know, we are talking about all these wonderful new technology coming in, but who is going to actually learn about those and utilize those to develop our future aircraft? We need to prepare the right kind of individuals who can actually do that. And don't wait for some university, somebody else to do that. I think collectively, we have a responsibility to go figure out, working with universities, working with industry, working with industry experts, how we create, you know, that next set of youngsters who will blossom into future leaders in aerospace, very, very familiar with all the new stuff that we were talking about. These are just 2 topics, and there are others, I'm sure. For example, you know, what is happening with the supply chain, especially the small and medium industries? What are they facing currently in the coronavirus situation? How do they get out of it? When they get out, do they do the same thing they were doing before, or do they do something different? How do they prepare for that? So lots of interesting topics that we still have left on the table to discuss. So like we said in the opening session, we have a need to come together. We have a need to collaborate so that we can find solutions that we all can benefit from. And in SA India, we have already started the dialogue. We have been talking to leaders in CII as well as a group called BCCI. Both groups have interest in aviation, and there are other groups that we really haven't connected with yet, but we intend to. We have connected with some. We have some more to talk to. So if you have interest in this topic, do reach out to us. Send a note to SA India. Tell us how you experienced these last 2 days, what you would like to see. We want to create this community, strengthen this community, and then we want to continue having these dialogues over the next weeks and months. So that's our ambition. So Venki started saying, set the bar high. I'm setting a new bar for you. We have talked a little bit about this in the committees, but I'm maybe setting a new bar for you, because that's the only way we are going to thrive together. So please watch your email for more information on these other programs that are coming. If you are interested in working with us, please let us know about that too. It's not only a few people that should work. We should work together on this. We look forward to continuing on this journey in the weeks and months ahead. And thank you again for joining us for these 2 days, and look forward to connecting with you again shortly. In the meantime, stay safe, stay healthy, stay inquisitive. There's a lot of interesting things going on in the aerospace world, and have a great day ahead. Thank you very much.
Thank you, Dr. Bala. I think it is as inspiring as any of your meeting and speech. Thank you so much. Ladies and gentlemen, now it's the time for VOT, or I would say EVOT, the E version of word of thanks. And we owe deep gratitude to all those who worked with us, whom we worked for, and who influenced us during the last 15 months of this Aerocon journey. It all started with one dinner meeting and then one discussion. I will tell you about it in a moment. A comprehensive list would run into several pages. So with profuse apologies to those omitted, and acutely mindful of the dictum that the debts one owe vastly exceed those one acknowledges, let me, on behalf of SA India Aerospace Forum, SA India Managing Committee, SA India HQ Office, and Aerocon SC and OC. In the trenches were those who helped and contributed on a daily basis, and without whom no consistently serious and quality output could have been produced. SA India owes a big thank you for you, the members of aerospace community, attendees. You are the reason for our existence. Thank you, members. I have a dream boss, Dr. Bala K. Bharadwaj. He gave me freedom and support to be a hyperactive DDG while also being a shield, protecting me from the consequences of my overreach. Thank you, Dr. Bala, being the torch and confidence when catastrophes occur. And as a token of our appreciation, we will give you the E-bouquet. Thank you. So,
all right, E-bouquet collected.
Yes. That is from Kotorpuram, Chennai to Whitefield, Bangalore. Thank you. You can come with the camera next time. Give me a moment. The next executive is more of an SAE Indian living in the US. Normally, it is a tricky part if one wants to be a boss, advisor, guide, and also a philosopher. This executive is all rolled into one. the one who had a vision of Aerocon coming in as early as 2018. The first discussion stated in a meeting somewhere in October 2016 when he visited Chennai. I was just 1 month old in SA India. The executive who loves South Indian cuisine, speaks Russian fluently, and by choice working out of Pittsburgh, US now. Murli, it's a big day for you. Election results are coming in. So I am talking about Mr. Murli Iyer, Global Executive Advisor, SA International. Thank you so much for all the guidance and support, Murli. Please accept our e-bouquet. Priya, why don't you come in? So I know he's not on stage. Give a round of applause, not the e-applause, regular applause. Thank you for all your support, Murli. Have a seat. We at SA India would like to recognize the efforts executed in the background by Dr. David Shutt, CEO, SA Enterprise, Dr. Raman Venkatesh, COO, SA International. We at SA India owe thanks to a few Indian aerospace industry captains we turned to for help in understanding specific issues, and they were quick enough in offering their help. Apologies if I am not pronouncing all the names due to a lack of time, but we would like to definitely thank these three gentlemen. Mr. Kiran Kumar, former ISRO chairman. Thank you so much, Mr. Kiran Kumar. You can have an applause. Thank you so much. Dr. Kota Harinarayana, former program director and chief designer of light combat aircraft and a fellow of Aeronautical Society of India. Thank you so much, Dr. Kota. Mr. Ashok Varghese, Director, Hindustan Institute of Technology and Science, Chennai, who is always ready to support SA India if it comes to aerospace. And the good news is that this institution is offering their willingness, land, and the auditorium for the sequel of events which will be coming up. In fact, that takes us to the announcement of sequel of events. But before that, thank you, Mr. Ashok Varghese. Our special thanks to all the 34 speakers who have almost readily agreed to support. Due to lack of time, I am saying a group thank you and a group applause on behalf of Aerocon SC, OC, MC, and office to each and every one of you. Thank you, speakers. The group of speakers consists of several CEOs, technical fellows, vice presidents, divisional heads, delivery heads, and mostly senior aerospace industry executives. We are. Thank you again. We could have attempted nothing, much less accomplished anything, without Mr. Javaji Muniratnam, Chair Aero Forum, for his relentless enthusiasm, encouragement, and positivity.
And fight.
Thank you, Javaji Muniratnam. Usually, if you're a movie director, you complete the movie, send it to the nomination committee, compete with international Jambawans to achieve an Oscar. Correct? Yeah, I see few nods. Well, if your movie has substance and selected by Oscar nomination committee. Correct? And if you're a scientist, you will have to complete technical papers, years of research, citation, technical conferences, fulfill several other technical requirements before you become a distinguished fellow or a fellow. Surprisingly, ladies and gentlemen, Aerocon 2020 was gifted an award even before we started the execution. You want to know who? Can I call Aisha to give a e-bouquet to Dr. GVV Ravi Kumar? Thank you, Aisha. Do let us know once you receive it in Electronic City, Dr. Ravi.
Can you come online?
Dr. GVV Ravikumar, Chair Technical Committee, for all his late night calls, cool and composed posture in all meetings, early morning calls, WhatsApp messages, coordination within Tech Committee and with Aero leaders. Thank you so much. You are the Oscar of SAE India's Aero Forum. Thank you so much.
Thank you. It's an honor. Thank you.
Thank you. Special mention to all patient hearing of members and industry captains. This executive not only chairs the Bangalore section, also chairs the finance committee. Mr. M. Kannan, General Manager, R&D, TVS Motors. Thank you, Mr. Kannan. I won't be doing my job a justice if we don't thank our sponsors. ANSYS, title sponsor, thank you so much. You are one company, you've been with us, whether it is this program or that program. And thank you for your continuous support, for all the ready reckoners or all the questions we keep asking. Thank you, ANSYS. Dassault Systems, principal sponsor, thank you so much. Infosys, platinum sponsor, thank you so much. MathWorks, platinum sponsor, thank you so much. HCL, gold sponsor, thank you so much. Hexagon, gold sponsor, thank you so much. Moog, silver sponsor, thank you so much. Hindustan Institute of Technology and Science, silver sponsor, thank you so much. The next round is organizing committee members. I could say more about all their distinctive contribution, but I only extend our profound thanks to some of them, and you will get your e-bouquet soon. Mr. Vasant Kini, MD of Titanium Industries. Thank you, Vasant. Mr. Ravi Shankar Mysore, formerly Vice President of Collin Aerospace. Thank you, Ravi. Mr. Uma Maheshwar, Chief Engineer, GE Aviation, for all his straight comments and bringing in agility to organizing committee. Thank you, Uma. And Maslegar Saab, Director, Business Development, SASMOS, for all his contacts in the industry. You name it, he says, "Main hoon na." Thank you, Mr. Maslekar. Here is another gentleman worth mentioning, more than worth mentioning, whether it is 10:30 in the night or 7:30 in the morning, and then very soft voice, but get things done, always calm and composed. Kripal Arpula, Engineering Leader, Senior Manager, Boeing India. Thanks, Kripal. I think the event directory and many other things. The WhatsApp messages, he says, we are volunteers, so why should office take so much? We will take it. Thank you so much. And Mr. N. Shekhar, President of Aerospace Industry Development Association of Tamil Nadu. Thank you, Mr. Shekhar, for readily agreeing. And in fact, they have sponsored, they've offered some discount from their side and brought in several registrations to Aerocon. And Mr. Prasad, CEO of Agnito Insights, for socializing Aerocon, publishing social media calendar. Thank you, Prasad. My apologies if I don't mention all of the organizing committee members. My thanks, our thanks goes to everybody. And then technical committee, this person who brought in Dr. Sivan to one of the conference, and that is when we got introduced. And then this person always thinks of systems. Dr. Ramakrishnan Raman, fondly Dr. Ramki, Principal Systems Engineer, Honeywell. This person, Dr. Ganga Reddy, Delivery Head, Aerospace and Defense, HCL Technologies, did a lot of background work in the technical committee. Thanks, Dr. Ganga. Like in the WhatsApp group, Muni said he's the firework, and Dr. Ravi said he's the new face of A&D. The young and energetic Mr. Dinesh Manoharan, Manager A&D Division, UCall. Dinesh, thank you. Another person, young, energetic, always the link or the ambassador between his institution to SA India. You want something from ATC, get him. You want something in UAV, get him. You want something in hackathon, get him. Mr. Karunagaran, Assistant Professor, Aerospace Department, Hindustan Institute of Technology. Thank you so much. In the innermost circle, ladies and gentlemen, I wanted to thank the background warriors, not the back end office, but background warriors, without whom we wouldn't have achieved this Aerocon successfully. Mr. D. Sheshadri, Executive Director Marketing.
Can they come on the stage?
Our $1 million man who worked tirelessly to drive sponsorship of 19 lakhs to Aerocon 2020.
Thank you.
Mr. Ilangovan, Deputy Manager PDP SA India, for working through weekends, dawn or dusk, and all through with a yes sir attitude. Thank you, Ilangovan. Miss Aisha BV, Digital Connect Officer, SA India, with her calm and engaged presence, shepherding the event from conception to execution to whatnot in the digital media, be it Glue Up or TownScript. Thank you. One special mention to this individual who worked in SA India, who brought Visita to SA India live. Now he's the Vice President of Brand Blitz, and he has put together the DEM, Digital Event Management, who is well coordinated with the entire proceedings of the conference into a recorded one with TownScript. Thank you, Mr. Vijay Anthony Babu. And final thanks to our TownScript guys. Yes, we had some issues, but I think they were ready to resolve and put everything together. Today is a fantastic smooth flow from beginning till now. So thank you, TownScript, Raj, Prapaga, Himesh, and the entire team back in Pune. So ladies and gentlemen, I won't do justice in my word of thanks if I fail to mention the overwhelming support given by our professional members of Aerospace Forum and attendees of Aerocon 2020. You are the reason of our existence. Once again, thank you so much. So I'm going to end with one wish and then one announcement. One more minute, I'm going to finish it on time. One announcement is Aerocon is not ending here. We have a sequel of events sponsored by Hindustan Institute. We also have planned a DRDO Day, which is basically about the military aerospace expertise. And then we have something exclusive for students. And we have series of webinars through WebEx, of course. We have planned it from today, 6th of November, to the beginning of Aero Show in Bangalore in February 2021. The calendar will be uploaded. It is in work in progress, and the same technical committee team led by Dr. GVV Ravikumar will work on it, and the same sponsors will continue. And the good news is that if you have or your organization has paid the fee for Aerocon 2020, then that is valid for all the events from now till February 2021. We only hope that the situation will improve in your city, in our country, as far as Corona is concerned. And we would like to end here with a great wish that it's going to be a great Diwali. Happy Diwali to all of you, and good night.
Having been involved with aeroplanes all my life, since I was a small child, I've just been fascinated with flight, and I've been involved in almost all aspects of aviation. And then to have this program of work now to develop the world's fastest electric airplane with companies like Rolls-Royce and like Ansys, it just amazes me, the technology that's out there and the ability of other people and companies to help put this together.
The Excel project will deliver an all-electric aircraft over 300 miles an hour. Competition has always been a strong driver of technology, and what we're really hoping to do here is use that competition to push battery technology, to push powertrain technology into aviation fast.
What we've learned in this process is with this type of energy profile, we're discharging the entire pack in a very short amount of time to achieve the record. So that puts a large cooling requirement on the battery system. And in this case, we're actually using the case as a structural member. So there are some significant challenges around optimizing both those structures. So ANSYS Fluent is being used to balance the cooling system pre-production, pre-prototype on test. And Discovery Live has been really important for us. Not only are we using their tools to help analyze the final design, we're informing the design on the way there. So again, not only are we doing less iterations in terms of manufacture, but even in terms of test runs, which we're really optimizing down there. So the ANSYS tools have been really key, and it's been a great partnership.
I'm kind of hoping that we can inspire the next generation of engineers into this new technology, and to be involved at the very beginning of electric aerospace is very exciting.
A harbinger of technology, the aerospace industry has incubated, nurtured and matured advanced technologies, right from composites to drones. Infosys is a proud partner of leading aerospace and defense organizations across the value chain, from original equipment manufacturers, suppliers, airlines to MROs, delivering value-driven engineering and IT solutions. With its bouquet of services catering to the aerospace sector, a vast pool of designers and consultants, and a flexible delivery model, Infosys has helped its partners scale greater heights. For instance, Infosys has supported a major aerospace original equipment manufacturer through Tier 1 supplier in designing and developing its composite nose section, which included design, analysis, manufacturing support and repair solutions. For a Tier 1 supplier, we built a cost-based portfolio of 200,000 parts, and proposed design and process optimizations through value engineering. This resulted in savings of approximately $250 million. By constantly adapting to new techniques, and by leveraging emerging technologies, like blockchain and artificial intelligence, we innovate and build state-of-the-art solutions for our clients. Pioneers in adopting advanced digital technologies early, Infosys has invested in building comprehensive skills, solutions and platforms in the digital space. For instance, Infosys, in partnership with Pori and Nokia, developed Kriti 4.0, an AI-based solution. It enables original equipment manufacturers and Tier 1 suppliers to enhance the reliability of operations and maintenance on the manufacturing shop floor. Another example is the Infosys Genome solution. It provides an analytical framework required by original equipment manufacturers, airline operators and maintenance service providers for capitalizing on data and predictive analytics to deliver a world-class flying experience. To learn about these and other such solutions, join Infosys today in this journey of transforming the future of the aerospace industry.
Hindustan Institute of Technology and Science. Take your first step toward a future in excellence. For over a century,
pioneers of aerospace and defense have dared to redefine the extent of what's possible. But the challenges are increasing dramatically. As populations expand, more people are flying, and the need for quieter, greener and cleaner hybrid, electric, and hydrogen-powered aircraft is imminent. Disruptive players, technologies, and new methods of urban air mobility are forcing innovation at unprecedented speed, exploring uncharted horizons, commercializing space, restaging the moon to explore Mars, and allowing humans to live on other planets. It is time to reinvent the sky, empowering innovators by simulating real-world conditions in a virtual world. Using collective intelligence through cloud-enabled innovation, progress is fueled by the agility and efficiency of the future factory, transforming supply chains through digital continuity, and deploying additive manufacturing at industrial scale. By accelerating development from concept to operations by up to 50%, Dassault Systèmes 3D Experience Platform empowers companies to solve the world's challenges, ensure a safe passenger experience, and create a sustainable future by harmonizing product, nature, and life. In a future made possible by virtual universes. Experience the future today.